Okay, so hopefully you'll hear me. If you don't hear me, then sorry, that's maximum what I can speak. Some of you asked what does for real mean. This means that I will try to explain things which I have learned over the past few years, not from hello world applications, okay? That's my definition for real. If you want to learn more about hello world application, ask Google and it will tell you everything. So my name is Anton Babenko. I'm AWS Community Hero, and I've been doing quite a lot in the open source. And specifically, I like to develop Terraform AWS modules, and in general, kind of popularize Terraform so that people use it a bit more efficiently. Don't reinvent the wheel. Try to come up with something what will work in current version of Terraform and also in the future version of Terraform. So we are not using any fancy feature which you may have heard from HashiCorp as like, hey, you should use this feature. No, please don't. It's full of bugs anyway. So yeah, but in general, I like to keep code clean, documented, and validated, and TF-linked, and all these kind of cool and fancy things is part of pre-commit Terraform project. Some of you may use it. Right. Or actually, raise your hand if you use Terraform AWS modules or pre-commit Terraform. Right? Oh my God. Oh my God. Well, that's pretty good feedback. So thanks everyone for using that. Then I don't have to talk about other projects. You already know it. But Terraform best practices is a place where I, in 2018, I started gathering information when I travel on conferences and talk to customers, and they say like, oh, this is what we use, or this is what we feel, and there was a lot of complaints and a lot of fights between my best practice is not, is actually better than your best practice. And I decided to write this down into terraformbestpractices.com. Currently, this website is translated into 15 languages. Swedish is coming, and yeah. Well, Swedish is one of the languages which was common for a very long time. If you want to translate it to Finnish, let me know, or any other language too. Okay, so when COVID started, I decided to not travel for obvious reasons, and I decided to share information through newsletter. So Terraform Weekly or weekly.tf is the project which I have accidentally adopted. That's how it's called. When somebody says, I don't need this project, I said, I will pick it up. So I start publishing news there and shared information which I discovered. And I also started a live stream where I talk to different creators, do different Terraform tools reviews. And most recently, I've been doing a lot of Terraform AWS modules live coding. So if you want to see how exactly I do certain things or how I fix bugs or do code reviews. And I can also answer many of your questions in real time, so don't hesitate to reach out. I do this every Friday, except when I'm traveling, same time, 12 p.m. Okay, enough about these projects, because I honestly don't know how long time I have, but anyway. I think I have 40 minutes. So yeah. So Terraform AWS modules and serverless TF. Terraform AWS modules is collection of more than 50 open source repositories supported by the community with quite large number of users. The project started because I didn't want to have the same process repeated over and over. So when you spin up your VPC, it shouldn't be so unique, same as EKS. There are certain things which you should be using, and that's why this project exists. And during last 2 years, two and a half years, I have been working actively on different serverless components, and I figure out, like at least I thought, that I figure out what is the main challenge of doing serverless on AWS with Terraform. It turned out that a lot of people struggle with it and nobody could come up with a clear solution. So the main block which I made was development of Terraform AWS Lambda module, which I will be talking later through the presentation, and I will show more about it. So all of this is pretty much sponsored by many people. And yeah, if you are using it and don't sponsor it, consider doing this, because otherwise I cannot continue. I don't have full-time job, if you're wondering, because, well, I don't have time for full-time job. Yeah, so let's talk about sample serverless application, or how the typical architecture looks like. Okay, we already have heard quite a lot about different types of services. So here on this diagram, I showed very simple and very primitive architecture, which includes an API gateway, a couple Lambda functions, which can do something with DynamoDB and log into CloudWatch. Also, there are some IAM roles needed for that. So very simple, right? And you may think about, okay, what is actually serverless here? You already know that serverless, like what is it? I'm not going to repeat that one. All I want to highlight is that in my understanding of serverless, like what we should be focusing most of the time is that we write actually application code and we don't think so much about management of the infrastructure. So that's where most of our energy, most of our time and efforts should be placed. We should figure out how to write pretty much Lambda functions, if we are talking about Lambda functions. We are not talking about step functions or any other configurations or any other things. So writing just Lambda function on this architecture, that's the key. Normally, we use, like even if we don't use serverless, or if we use serverless, it doesn't matter. We would like to use Terraform to manage the rest of infrastructure, right? We may have some VPC, we may have some buckets, some other resources. So we already use Terraform. So think about this is that we use Terraform for managing all kind of different services, and we still want to have our Lambda functions as close to us as possible, so that we want to focus and spend most of our time actually writing this code, testing it, and doing something with it. So let's look into some of available options. Available options usually include using something what is, as I call, default, because they have serverless inside of their name, right? AWS serverless application name, probably it is serverless, right? Or serverless framework should be serverless because it says serverless in the name. So that's what people have been using, and people are still using it very actively. But also there is another thing when it comes to the infrastructure. We have plenty of options. We have Terraform or CloudFormation, CDK, and you name it. I mean, you know all of these tools exist. So you may think, okay, I have my serverless framework, for example. I have something to manage infrastructure. And of course, I need to have some sort of glue, which is typically shell script or make files, where we script all of our deployment processes and we just orchestrate deployment, pretty much running some SLS command or some Terraform apply commands. That's what typically we've been doing. And of course, the last step, which is unfortunately impossible to to skip, is that we periodically have to go through yak shaving and rabbit holes. This, unfortunately, is a reality which takes enormous amount of time, which is impossible to predict in advance. And unfortunately, I don't know any other option. If you know how to avoid yak shaving and rabbit holes during work, please tell me. ChatGPT doesn't know. So if we look into this like typical problems and challenges, there are actually too many overlapping solutions. You may think CloudFormation and Terraform, well, they can do similar things, right? But if you use, let's say, serverless framework, it will generate CloudFormation, but you are using Terraform for something. So it's already some sort of overlap. And accidental complexity is the main thing which I have figured out. I actually went to Wikipedia to figure out this term, and I was so proud that I found the definition, and it matched exactly my feeling when I think about serverless couple of years ago is that in order to have my job done, I need to do a lot of extra hops to understand. My experience with serverless framework in particular was that I used to understand how plugins work. I write a lot of code in Python. For some reason, I need to do a lot of understanding and patching and debugging of JavaScript, because that's what they were using. And this accidental complexity pushed me far, far away from actually writing my Python code, running Terraform apply, and that's it. So I used to do quite a lot of these things which I don't want to do. And also, if we are talking about overlap in infrastructure management, we often may have such discussions where you talk to somebody and they say like, oh yeah, VPC is traditional resource, and we manage traditional stuff using Terraform. Okay, fine, but Lambda function is serverless, so we use SAM or serverless framework for that. Okay, but what about IAM role? Where do they belong? Is it traditional or is it serverless? Or should we combine these two tools and depending on where this IAM role is used, decide which configuration file to put it into? It's already an overlap, and you have to spend extra brain cycle to come up with solution, and then you will have to protect this solution. It's often unnecessary. So let's look into alternatives. So when it comes to alternatives to these problems, as I said earlier, you should be spending much more time writing your application code in the language or using tools which you are already familiar. And infrastructure code, you are already using Terraform for most of your infrastructure. So try to avoid too many overlapping solutions. And very important is that you should not think about where does this resource belong to this module or to this tool, to serverless framework, or maybe to SAM. But no, it's actually used only inside of traditional, so it has to go into Terraform. It's all things which shouldn't be even discussed, preferably. And when it comes to accidental complexity, again, try to understand that your Lambda function is what actually brings value, and focus just on writing that one. And as a result, try to avoid looking into internals of different plugins, libraries, or modules if you can. So for this reason, Terraform AWS modules can be just used. We are utilizing the same patterns across all of them. Across all naming conventions is identical there. Compatibility promise is the same. Versions is very similar. So in order to use one of the module, you should not study the source code of it or look into examples or run them. They're already there, and and you can look into them since it's open source, but you should not be looking into them right away. And overlap in infrastructure management. Anyway, you prefer Terraform, right? Right. Okay. Yeah. I see. That's good. That's good. So then I'm in the right room. Okay. And this is how a serverless TF project started. So there are two URLs where you can read it. Serverless TF is website. TF is territory of France in Indian Ocean, if you wonder. Yeah. So serverless TF highlights. First of all, it is really decoupled set of modules for all kind of tasks when it comes to services, like to AWS services, when it comes to building, packaging, deployment, management, login, all kind of things which you do inside of your typical serverless application. And Lambda module in itself implements pretty much all Lambda-related tasks, which means that it can build and it can package and deploy in almost countless amount of combinations using and supporting all languages out there. There is no difference which language are you going to use. The only requirement which it has currently is that you have to have Python installed on your machine if you want to build it, because that's where the magic is happening. If you will be building your package on your CI, because you use, for example, .NET, and you want to build it somewhere centrally, then you don't have to have Python even on the machine where you are using this module, which means you can use it on any hosted Terraform automation platforms like Terraform Cloud, for example, where you don't have Python installed. And focus on application logic and use Terraform for everything else. When I say everything else, is that I want to emphasize that Terraform is really good to handle all relations between all of your dependencies. So imagine that you already have a lot of resources and you run Terraform apply, and Terraform magically figure out what kind of things has to happen, like what kind of things has to be updated, in which order, and so on. And when you are adding one resource into this graph, which is called application, it also has some dependencies. For example, it has dependency on which requirements txt version you have. And if you change something there, Terraform will be in charge of understanding that it has to install something what is updated inside of requirements txt. Then it will have to package it, it will have to upload it to S3, and it will have to deploy from this S3. So Terraform will be doing all of this for you. You should be aiming, in most cases, to treat your serverless application and infrastructure as code all at the same time. So there is seldom an exception where you may want to treat your serverless application slightly outside of your infrastructure as code, because then you will have to have a couple pipelines at the same time, right? First will be producing your, or taking care of your application itself, like building these Lambda functions, and infrastructure as code will be picking up these zip files from centralized S3 bucket, for example. But in most cases, especially for small projects, it's almost no-brainer that you have all of your SRC files somewhere, and you have Terraform configurations next to them. And in order to deploy it somewhere, you just run Terraform apply, and that's it. It's also fully open source, as pretty much almost everything what I do is open source. Well, I have some demo. Who wants to see demo? Cool. I don't have internet, but I still have demo. Well, actually, you don't see anything, of course. Right, that's going to be a challenge. Does this work? Yeah, well, fantastic. Okay, so yeah, you should be able to see it. Yeah, more or less. Okay, so what I want to show this folder 2023, this is like when I update this presentation. Here you can see some files like with extension TF, which means that Terraform will be using those. And in order to make this architecture, here is what I did. So if we look from the left side, we have an API gateway. API gateway is already an existing module. So there is a module for API gateway v2, which currently does not support WebSocket, because apparently nobody is using WebSocket with Terraform, or nobody was able to come up with pull request. I don't know what's the relation there, but anyway, there is a module which clearly integrates with Lambda function in order to do get, then call this module get Lambda function IRN, and if it's post, then another module. So all configuration which you have to do is already available here. And if we look into the module block for Lambda get, it's pretty much like this. So we are calling Terraform AWS module for Lambda, we are providing a bunch of different properties here, and we specify that we want to use source path from the location which is nearby, just one level up inside of src folder Python function. So here is the simplest way how we can specify this configuration. We are providing string to the folder, and then it will be Lambda module which will look into this folder, and it will understand whether you have requirements.txt or npm project, and it will do quite a lot for you in order to install packages or install different dependencies. It can also do compilation in Docker, accessing private repositories and so on. So it actually implements almost everything. Well, I don't want to say everything because now somebody will come and say, hey, it doesn't implement this feature. Well, I don't know what it doesn't implement, to put it this way. Because there are a lot of users and a lot of situations where you want to compile something for another platform. Like we use it to compile, like on my Mac, we compile something natively, like some binaries for Linux, and we put them into this package and we deploy them as well. All of this is supported by the module. There are a lot of different configurations how you can do this. Similar configuration or similar flexibility is for handling different properties which typically Lambda function has, like attaching different policies or attaching X-ray policies, attaching different IAM policies for specific resources, for specific actions. All of this readability is very important, that it's not scattered across different resources. When you are writing your module like yourself, most likely you will implement subset of features which you need only right now. And that's why there are a lot of Lambda modules out there where people implement something very specific for their use case and they're happy, and then they come and say like, yeah, but we have a module, it works for us. Great, now try to extend it so that your next function which you will be writing in some other technologies is also supported out of the box. Or a new feature which is added by AWS or by HashiCorp Terraform provider is also implemented. So it's going to be always race, and you will always try to implement something what was added pretty much yesterday. The point of using these modules across is that as soon as new feature is added into a provider, we have support. For some features, we have the zero support because we are watching this very closely. For some features which are available in Terraform AWS module, we have, for most of them, we have week 0 or week 1 support. So when something is added and none of us is traveling, then we can click merge button and it will be automatically a new version. So look into this one as a way to manage all of your Lambda related attributes, as well as allow triggers, and it supports everything else what typical Lambda function has. If I look into examples of this module, just to show what else do we support, all kind of async invocation, aliases, code sync, sign-in, and different deployment strategies, support with Elastic File System, with VPC, and yeah, and a bunch of other things as well. Event sourcing, event source mapping is quite heavily used. So that's this one. And another module, if we look into this diagram here, is DynamoDB and ACM. ACM is not on diagram, but it's needed. So here is the configuration for ACM. You may think that ACM is simple resource and you just need to create it once. That's true, you need to create it once, but again, it looks simple. If you look into these 5 lines of configuration, it is simple. But when it comes to extending this, when you suddenly want to use not Route 53 to create these verification records, but you want to use another DNS provider. This is also supported by this module, and it has been used by some people. So that's how it works. When there is demand, then we contribute it there, and we maintain it pretty much forever. Similar modules are for DynamoDB table. There is not much to talk about, I guess. Similar code is actually for Lambda post. As you can see, it is very similar configuration, just another policy statement, so that DynamoDB can write into this DynamoDB table. No big differences here. So that's it. I didn't run, well, I can run it, but it will take like 5 minutes, and the output will be just a bunch of different attributes. So it's, yeah, and I don't have Wi-Fi, so believe me, it works. Who doesn't believe? I see. Okay. I'm calling the police. Okay, well, that's pretty much it for the code. Let me go back to this. If you have questions, you will have time, because I'm almost out of content. So let's talk about some features of this Lambda module, which is essential part, and it has been downloaded, or it is downloaded more than 50,000 times a day. That's only what I can see from public. Also, a lot of people, for some reason, prefer to fork it and put it behind their firewall, and now they're maintaining this stuff. Okay, if you want, you can do this. So Lambda module can support many different arguments in source path, so that you can make your Lambda package consist of different entry points. So for example, you can compile something in one place, like for one architecture in Docker, then you can install something with pip, put some npm dependencies. I don't know if you need to merge all of this in one, but you can if you want. In most cases, you will be happy with using shortcuts for technologies which we added, like pip and poetry, and npm has native support. For all other things, you will have to write your own commands, like if you want to use .NET, good luck, but it's supported. As well as pretty large amount of combinations when it comes to building Docker images. So you may have your custom Docker image which you want to use, or you can provide just Docker file. You may access your private registries and so on. All of this is in use, and if there is something not working, the community is very active and they fix it or discuss it right away. When it comes to reusing existing package, you can create new package and put it into S3. Again, it's feature of this module. You can have your package present locally. For example, if during your CI/CD process you download something from some source, and then you have this artifact locally, or you can point to specific versioned S3 object, and as soon as version change, then you can trigger deployment as well. All of this is shown as examples inside of the module already. When it comes to deployment, this is a little bit more kind of not verified, but it's a bit challenging, because usually doing control deployment in Terraform using code deploy is good. I mean, it works, it's supported by the module, but Terraform is not always the best tool to keep up and running for a couple hours. Because if you do, let's say, rolling deployment using AWS code deploy, it can take lots of time. And in many cases, you may want to just trigger it and then forget about it. It is also possible that you will stay and wait, and Terraform will be waiting for the successful deployment. but in some cases you may want to stop it. So simple deployment when you specify just publish through, same as you would do in the API call or in console, is typically a default option. And when it comes to integration, you may use pretty much any Terraform modules. When it comes to using serverless on AWS with Terraform, you have possibility to use absolutely anything what you want. There is no restriction. The serverless TF is the project which describe how certain integration can happen, but it's not like a CLI tool which you can run and it will do some magic for you. There was some intention initially, like, hey, let's do some CLI, but then it turned out that we cannot make anything better than Terraform apply. Like, what else should this tool do? If there would be any need for that, we would rather put this into Terraform provider. For example, currently we have quite messy and quite complicated package py file, which takes care of packaging in different combinations. And I believe that this file should be just a resource in Terraform, so that you provide a bunch of different configurations to it, and Terraform takes care of how these things has to be changed. Using data source archive file, as some people use by default, is extremely limited. If you want to know what exactly is limited, check out issues. There are a lot of things not supported, like you cannot specify list of files with regex in it, for example, like patterns of directories to include or to exclude. And in general, integrations through Terraform providers is very useful. So if you think about using Terraform AWS module to handle a bunch of different infrastructure components and, let's say, use Cloudflare provider to manage DNS somewhere, or use a REST API provider to notify, or not REST API, but HTTP provider to send post request to certain endpoint when everything is done. All of this exists in Terraform providers. So you can just use them, and again, all what you will have to do will just run Terraform apply, and it will just do the trick for you. When it comes to CI/CD with serverless TF approach, often people prefer to split package building and deployment into two separate phases. So when you build something, you build it once, and then you propagate this change through different pipelines steps. So that's why there are ways how you can use this module, like Lambda module, to create package, but don't create deployment, for example. And another block may use previous artifact and actually handle just deployment. There are examples for this in Lambda module too. You should be always able to run Terraform init plan apply locally. No matter what other people say, like, oh no, we are a bank, everything should go through pipeline. No, not everything. You should be able to have your access to your pet environment, local environment, call it anyhow, where you should be able to run pretty much the same pipeline. It will save you tons of hours. Sometimes I talk to companies who say, like, everything is pipeline. Yeah, but then you talk to developers and they're extremely unhappy because they need to wait for all this stuff being deployed slowly before Terraform raise some error to them, and then they come back. So it's like 2 commits per day. That's not really the most efficient way. So if you have possibility to run init plan apply locally within your isolated environment, which of course can be restricted, it should not be your production. I'm not saying that, but always try to come up with similar flow which you can run locally. And of course, if you have possibility to pay for tacos, you can run your own Terraform pipeline there. all of them do exactly the same things, no matter what marketing team will tell you. They all run pipeline which you define. And it has nothing to do with whether you use serverless or not. So serverless TF itself is pretty much, just honestly, it's just a collection of Terraform AWS modules to handle serverless. That's it. It's not framework, it's not CLI. I probably should put it as disclaimer. Yeah, that's a good idea for next time. Okay, so the application code and Terraform apply. In essence, that's all what it looks like. You have module block where you call Lambda module, and you have a bunch of arguments which you pass into this module. That's it. This is not more complicated than any YAML or any SAM configuration which you saw earlier today during other talks. And yeah, thank you, and subscribe to my channel.